with the continuation of the previous chapter, previous topic, nitrogen. Okay, production of dinitrogen, that is what we are going to see. How commercially dinitrogen has been prepared, that is due to fractional distillation that can be prepared. Okay, how it has been prepared due to the fractional distillation of air. Okay, it can be prepared large scale. In the laboratory preparation of dinitrogen, it can be prepared by treating an aqueous solution of ammonium chloride with sodium nitrite. That is, ammonium chloride and addition of sodium nitride, which will be giving dinitrogen, water and sodium chloride, where dinitrogen, when it is added with water, which will be it will be giving out dinitrogen, water molecule and sodium chloride. It also can be prepared by thermal decomposition of ammonium chromate, that is NH4 twice Cr2O7, potassium dichromate. When it is on heated, gives dinitrogen, water and chromate molecule. So these are the important thing. And along with this, one more example of preparing, that is barium nitride, which is called as azide. Barium azide, as barium or sodium azide can also be used. On thermal decomposition, it gives out barium or sodium plus nitrogen. Dinitrogen will be given out. Nitrogen has a isotopic property of nitrogen 14 and 15, which have very low solubility in water and have a very low freezing and boiling point. Nitrogen is inert at room temperature because of the high bond enthalpy of nitrogen and nitrogen triple bond, which will have one sigma bond and one pi bond. Because of that, it will have a high bond between nitrogen and nitrogen, so that it will be inert in the room temperature. At high temperature, it directly combines with some metals to form predominantly ionic nitrides and with non-metals, covalent nitrates. A few typical reactions are given there, that is lithium on reaction of nitrogen on heating, that is what, when heated, it gives out lithium nitride, and when it is reacted with magnesium, gives magnesium nitride. Okay, so these are the examples. And chemical properties of nitrogen, that is two isotopes, as I said, magnesium and reaction. These are the chemical properties. In the right hand side slide you can see. Okay, so uses of nitrogen, the main uses of dinitrogen is in the manufacture of ammonia and other industrial chemical containing nitrogen, that is calcium cyanide. It is also finds use whether it is where an inert atmosphere is required. Okay, so that those things are the examples. Some problems are given in your textbook. That is what, example 7.3, write the reaction of thermal decomposition of a sodium azide. That is not given in your textbook, where we have seen in the previous slide, that is sodium NaN3 gives 2 Na plus N2. Okay, so that is what the reaction. Why is N2 less reactive at room temperature? So that is what also one of the question given here. Why it is very less reactive at room temperature? Because of the answer for that is given here. Okay, it is inert at room temperature because of the high bond enthalpy of nitrogen. So that is what the answer for this, and that is what, and you can go through those things, how it can be prepared